Now we will see in this part of the clip random variable and probability distribution. Random variable and probability distribution. Random variable and probability distribution. So what is the meaning of this? Random variable and probability distribution. Okay, what is a random variable? Random variable is normally denoted by the letter capital X in probability. What is the meaning of this random variable is, it is a variable that takes any value by chance. Variable that takes any value, that takes values by chance. Okay, values by chance, which means when we say that if we are interested in finding out when a coin is tossed 10 times, what is the probability of getting 5 heads? Now X will take the random variable by that chance, correct or not? What we want to find out, that we take it as a random variable. Is it okay? Now what is the meaning of the word probability distribution? Probability distribution means if we write all the values that X can take like this, see all the values what X can take, X1, X2, X3, so on up to Xn, which repeats itself with certain probabilities of occurrence, which means if say X1 occurs with probability P1, P2, P3, so on up to Pn, then this particular distribution of this type, is it okay? This particular distribution of this type is called as the probability distribution. Then this is called as the probability distribution of that random variable. Now, here we should know one thing, sum of all the probability values, I is equal to 1 to n, that is P1 plus P2 plus P3 plus so on up to plus Pn, sum of all the probability values should be equal to 1. Is it okay? So, and mean of the random variable, which is also called, mean is denoted by mu, which is also called as the expectation value of X or expectation of the random variable X, which is denoted by E of X, which is nothing but sigma I is equal to 1 to n xi into pi, which means you multiply and add. Okay, first you multiply the respective values x1 p1 like this. This can be written as x1 p1 plus x2 p2 plus x3 p3 plus so on up to xn pn. This is nothing but mu, which is also equal to the expectation value of X. Do you get it? This is called as the mean or expectation of X. In the shortcut we can write this as n into p. This is shortcut. We have made use of this in the problems also. Mean or X can also be written as n into p, where n is the number of trials. And what is P and Q? I'll explain this to you. P is nothing but the probability of success. What is probability of success? If what I want, if I'm getting, then that is success to me, right? When I'm throwing a dice, if I'm looking for the number 6, and if I get the number 6, then that is success to me. So that is what. See, random variable might keep changing from one experiment to the other. In the first throw, I'm expecting a 6, but in the second throw, I might expect a number called 2. Then that becomes success to me. So random variable keeps changing its form. Do you get it? And Q will be called as the probability of failure. Is it okay? Probability of failure, such that Q will be equal to 1 minus P, or I can say that P plus Q. Success plus failure, everything will give you ultimately the maximum value as the probability of the sample space 1. Do you get it? 1. Similarly, if I say what is the variance of the random variable, variance of the random variable X, which is denoted by VAR of X. So this is nothing but a sigma I is equal to 1 to n xi minus mu the whole square. Is it okay? Xi minus mu the whole square. Xi minus mu the whole square into probability of I, into P of I, which can also be written as E of X square minus E of X the whole square. This is nothing but the variance of X. This is the formula for variance of X, but we don't have so much time to do all this in the competitive exam, no? So we make use of a shortcut, which is nothing but VAR of X, variance of X, that is equal to NPQ, where N is the number of trials, P is the probability of success, and Q is the probability of failure. So the standard deviation of X which is nothing but sigma x, can be written as square root of variance. Square root of variance. So sigma x can be written as root over npq. All these things should be known clearly. Okay, root of npq. Is it okay? Root of npq.